So, on your graph paper, go ahead and give me a y-axis. Give me an x-axis. Just take up like maybe like the top of your page, throw it away, please. Just like up here on your graph paper, like this big. Give me an x and y axis, please.
The chicken on here, what, mister?
Big time.
Ah.
So 1, 2, 3, 4, 5. I'm going to put -1, -2, -3. Do it on the lines. Just on top somewhere. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. Just go up to 5s for now. Give me an x and y axis. Make sure you use the grid lines of the graph paper. All right. Go ahead and plot a point at 0, 0. And go ahead and plot a point at 2, 1. Go ahead and plot a point at 4, 2. Do that for me. Just like you see it on my board. Okay, let's pretend that the y-axis represents, I'm just gonna make this up on the spot. Let's pretend that this represents burgers, hamburgers made. So the y-axis right here represents hamburgers, and the x-axis represents minutes. The phones are right now. The R stand. It's a respect issue. Minutes, burgers. Go to connect that line here. Just put an arrow. The arrow means it keeps going on. So let's just say, what's your favorite kind of burger, Gabriel?
My favorite kind of burger?
You go anywhere for a burger, where would you go?
Good question, mister. No kid. Well, like, to be honest, I don't really like burgers like that, but I'll eat them, you feel me?
I feel you.
But I like chicken sandwiches, chicken.
Gotcha. You ever try Hot Chicken Republic over here?
Yeah, mister, but I didn't really like it this time.
Why?
Yeah, mister, I went probably like yesterday, 2 days ago.
What'd they do?
No, I don't know, mister. They just put too much like powder, like it was too much chili.
I liked it.
Yeah.
That's good stuff. Anyway.
It just tasted like straight like hot tahini, mister. I swear to God.
That place is good though.
Yeah, no, I know.
With the coleslaw on it, the slider.
Yeah, like the bread and like the little fries. Smacking.
Rojas, what's your favorite burger?
My house, mister, should be whipping the kitchen at my house.
Seriously?
Nah, it's fine.
Go ahead, Ross. Valencia, what's your favorite burger? In-N-Out. Okay, so we're at In-N-Out. In-N-Out's burger rate. What's the rate? What's the speed at this In-N-Out joint is making burgers?
In-N-Out is probably like a 3
Wait,
out
wait,
of 3.
Oh, go ahead.
For 2 burgers, it takes a minute.
Right, so the rate, watch this now. Go to right. The rate is 2 burgers per 1 minute. You can see that. That's the rate. But here's the thing. It's also the slope. Way back from math 1. Remember the slope formula?
Nope. I remember it.
The slope formula was, watch this now, delta y over delta x. Fonseca, you ever seen that formula, delta y over delta x? Cruz, you ever seen that formula? Ontiveros, you ever seen delta y over delta x? Quintero? Yeah? Don't worry. Rojas, you ever seen that? Miss Valencia? Gabriel?
No, I've never seen that.
All right. How about this? You've probably seen this one though. Watch this. When I write slope in a different way,
Yep, I've seen that.
watch this. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That ring a bell?
Yep.
Fonseca's like, yep. Cruz, is that one recognizable? Ontiveros? Quintero? Rojas? Gabriel? Valencia? Okay. This is the math 1 slope formula. You guys are not in math 1 though. You guys are math 3. You're going to use this formula now. So, what language is that?
It's called,
Was African language?
no, that's called crybaby language.
Delta y, delta x. This is a Greek letter in the Greek alphabet, kind of like pi. But it's a triangle. If you look at the Greek lettering, there's a triangle letter, and that's called delta. And in mathematics, whenever you see the symbol delta, it means change. Put delta means change. The change of one value to another. Movement from one value to another. Let me explain. Come on, please, thanks. Watch this. So to find the change between any 2 values, so looking at this line right here of In-N-Out burgers. The coordinates that describe that point are x is 1 and y is 2. The coordinates that describe that is x is 2 and y is 4. Now, look what I mean by change. The change in y values. Look at 2 to 4. How much change took place from 2 to 4? To go from 2 to 4, what's the amount of change that has to take place? There's a change of 2 units. In this case, burgers. So to find the change between 4 and 2, all you gotta do is subtract them. Watch. 4 minus 2. And now look, let me do the change in x's. Change in x. Here's an x, here's an x. How far is 2 away from 1? Well, subtract them. 2 minus 1. Look what ends up happening. I'm taking the change in my y values, which is 4 and 2. Look at 4 and 2 are my y values. And then on the denominator, I'm taking the change between the x values, 2 and 1. I'm subtracting those puppies. That's how you take the change. Watch. 4 minus 2 is 2. 2 minus 1 is 1. Hey, that looks familiar. That's what Valencia said. Look at 2 burgers per 1 minute. So the slope is the same thing as the rate. And to find the slope, you take the change in the y values divided by the change in the x values, and you get your slope, which is your rate, which is your slope, which is your rate, which is your slope. I want to hammer in your mind that the rate is the slope and the slope is the rate.
So how would you write the slope?
How would I write the slope?
Yeah.
Like that, 2 over 1. But if we want to write the rate, what does a 2 represent? Oh, it means burgers. What does a 1 represent? Oh, that means minutes. So it's 2 burgers per minute. Good question. Let's try another example. Underneath that graph or the side, it's your graph paper, you can put it where you want. Here's example 2. Go ahead and make another x and y axis.
Too many y-axis.
What?
Too many. I got you.
Go ahead and put a point at 0, 3 and at 1, 1. So 0, 3 and then 1, 1. Let's go ahead and put, this is gallons, and this is seconds. So we're doing slope. You've seen slope in Math 1, junior high school, but now we're going to do a Math 3 type of slope, a little higher level now, where you got to know what slope means now. Slope formula. Delta y delta x. The change in y over the change in x. I'm going to show you 3 methods of finding the slope. Count them, 3. The first method, believe it or not, is with the end of my pencil, the end of my writing utensil. I'm going to find the slope. I'm not sure if you have a pen or a pencil in your hand, but watch it. I'm going to use this to find the slope. Watch. Let me locate the highest point on this line. Here it is right there. Now I'm going to ask myself, self, from this point to the next point, what's the change in y's? The y values would be vertical, up and down. See, this is because this is the y-axis, this is the x-axis. From here to here, what's the change in in y values? Well, 1, 2. Okay. Change in y's. To get from here to here, there's a vertical change that's up and down. From here to here, there's a vertical change of 2. And now, here's my x value. From here to here, what's the horizontal change? From here to here, horizontally. How much do I have to change? Well, it's 1. But the line's going down from left to right, so it's going to be a negative slope. A negative 2 over 1. But what does a y represent? What are we counting on the y-axis? Gallons. So this is negative 2 gallons per 1 second. I'm not sure what we're describing here, but it might be something that's draining. The amount of water is decreasing, so we're losing water at 2 gallons per second. That's why it's a negative rate.
Oh, yeah.
That's why there's negative. On the first example, That's positive. Second example, we got negative because the line is going down from left to right. So that was the pencil method. And look here, I went from here to here. What's my vertical change? 2. That's the look at delta y. The y-axis is up and down. And then what's my horizontal change? Horizontal means left to right. That was 1. Boom. And I knew it's negative because the line's going down. So that's the end of the pencil method. The second method is just using the slope formula. Watch this. Delta y, delta x. Let me pick any 2 points. Well, I got the points right here. Look at this. The points there are 0, 3. Here is going to be 1, 1. Gave up, Gabriel? Come on.
I already had it written down, mister.
Right here, right here.
No, that not.
Stay with me. Watch this. Delta y. What are my y values? Oh, it's right here. 3 and 1. So I'm going to take 3 minus 1. And then my x values are 0 and 1, right? Since I use this top point first, I have to use the 0 first. So I'm going to take 0 minus 1. Since I use the first ordered pair first for the 3 minus 1, when I do the x's, I have to use the 0 first. It's 0 minus 1, not 1 minus 0. I got to stay consistent for the formula. But it doesn't matter which ordered pair you use first. Since I use the top ordered pair first for the delta y, look at 3 minus 1, I have to use a 0 first for the delta x, 0 minus 1. Look what we get. 3 minus 1 is 2. 0 minus 1 is negative 1. We got a negative 2 gallons per second again. Even though the negative's at the bottom, it just makes the whole fraction negative. It doesn't matter if the negative's on the top or bottom, it makes the whole fraction negative. So negative 2 over 1 gallons per second, per 1 second. So far, so good. Hello? Hey, what's up? Why? How come you didn't call me? Got it. All right. Bye. All right. Look what I'm gonna do now. So first method is just the end of my pencil or pen. Second method is a formula. Third method, I'm using the formula again, but with different points. Watch this. So we went down 2 over 1. Okay, I'm going to go down 2 over 1. So that's 2, negative 1. Look at that point, 2, negative 1 is still on the line, the same line. Go ahead and highlight that on your graph. Plot 2, negative 1. And I'm going to show you what different points we still get the same slope. Right, Quintero? There we go. Let's do the slope again. Slope is delta y over delta x. But this time I'm going to use this point, x, the 1, 1, and 2, 1. 2, negative 1, rather. Notice, they're still on the same line, but I'm picking 2 different points now. Let me do the delta y, delta x with those 2 points, and notice I'm still going to come out to negative 2 over 1. Watch this. I'm going to use this ordered pair first, and this ordered pair second. In other words, I'm going to take this ordered pair, subtract that ordered pair when I do the delta y and delta x. Watch how I do it. So delta y, I'll go with this one first. I could have went this one first. Doesn't matter. Doesn't matter which one comes first. I'm just going to go this one first, willy-nilly. That means this one's going to be second. You got to decide which one's first and stay consistent. Watch. So the delta y's, my y values are -1 and 1. Here we go. -1 minus 1. Cool. Delta x's. 2, that's an x, minus 1. Nice. -1 minus 1? Hell, my coffee hasn't kicked in yet. Close. Right, it becomes, look at it. -1 minus 1 becomes -1 plus -1. I got a -2 over 1. Same, look at same flow, same slope. -2 gallons per second. Delta y, delta x. Last but not least, one last example. You can do your head puzzle. Give me one more graph here. I'll get that. Copy that down. So -4 chickens per 5 seconds. You divide it, it's -0.8 chickens, almost a full chicken, not quite. If you chop one chicken into 10 pieces, it's 8 of them for every second. So watch, look at -0.8 chickens per second. So almost a full chicken, not quite a full chicken, almost a whole chicken. 8/10 of a chicken for every second. That's how quick we're losing chickens here in this example. So on your DMT, I want this, not this. Even though technically this is correct, we express rates as per 1 second, not per 5 seconds. So you have to divide in the end and express the rate that way. I'm done for now. Save your notes because we're going to revisit these notes on Monday. Tomorrow's quiz day, obviously, and the movie, we're going to watch that movie again, Stand and Deliver. So we're going to revisit these notes on Monday. So save this. We didn't write on this. Save that for Monday. Go on to your Ed puzzle for now for your R stamp, and then the DMT. Have a great day.